Hello guys, welcome back to Data Analytics with Saeed, and today we're going to talk about what are the basic Python stats. So now we have advanced from we have now went to advanced, but now we're going to talk the basic advanced, and we're going to actually talk the advanced about it. So the basic Python stats, first let me show you what are basic Python stats. So uh, Here. So basic Python statics involves using Python libraries to perform common statistical calculations and analysis. So this is what we do as a data analyst. We calculate like statisticals and perform like analysis. We're using Python libraries. So now we're on to like the real big part. So now we're gonna talk about what are the libraries and basic Python stats. There's a lot, but like the most ones we use that are very like important is NumPy, Panda, Skype, and statics. So NumPy it provides supports for large multiple division arrays, very large, like pair plots, along with calculation mathematical functions to operate on these arrays. It is widely used in statical. It is widely used on statical calculations. Now, pandas. What are pandas? So, pandas libraries are offers data structures and data analysis tools. As maybe you can use like these are all the stuff. Like if you get a paper, you can get a scissor, you can get a pencil, paper pen, you can get a color pencil. These are all the tools, just like Panda. And it's also useful for handling structured data and performing various data manipulations and analysis tasks. SkyPy. It's libraries that build and provide additional functionality, including models for the optimization, integration, interpolation, and all of these we're going to talk about in the future video. Now, statics, this model provides function for calculate basic statistical properties of data, mean, median, mode, and standard division and variance. So, what are the Python stats? So, the basic Python stats are mean, average, which means average, median, this means the middle value in a sort list of numbers, mode, the value that appears most frequently in a data set. So, if we have, I will show you guys soon. Variance measures a spread of data points from the mean. Standard division, the square root of a variance, providing a measure of the dispersion of data points. So how to code basic patterns like mean, median, mode, variance. So first, we're gonna create a data. So data is assigned to brackets 2, 3, 4, 5, 6, 7, 8, 9. So now this will be, so over here, now we go mean. NP dot mean data. Now it's the total sum of numbers of terms. So right here, when we the mean is here. So the mean of data is 6.2. Why? Because uh here first let me delete these so it doesn't confuse you guys. Let me go back now. It's gonna take a while, but now it just means total sum of numbers of terms. So total sum. So we add all of these, which is probably gonna give us, I guess, 62, probably no, probably 40. Sorry. So right here the reason we don't get it is because we have to go all the way back import. Let me just do this. Here. So the mean total sum of numbers of terms. So total sum is probably like uh if you can calculate it, here let's use this most. So we're gonna use scientific. So if we do 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, 9 is gonna give us 44 and divided by 10. Now 44 divided by how many numbers do we have? One, two, three, four. So we basically have 8. So 8, we get 5.5, and the calculation over here is 5.5. So median means the middlemost element. So the middlemost element is 5, but you can see that there's 4 on the right and 3 on the left, which doesn't really make sense. So we do 5.5. Because it's kind of be in the kind of in the very middle, so it's gonna be 5.5. Now, now if I remove this and control, see now it's 5 because 5 is the middle. So now we're gonna go back. So 2 means most repeating item. The most repeating item is none. It's getting a error because there's nothing. If I do boom here, it's 9. See, 9 is the most repeating because it's repeating 2 times. So that's what mean, medium, and mode means. So now how we can calculate the standard deviation is we understand it, the meaning or the mean. So std underscore dev equals np dot std data. The variance equals np dot var parentheses data. When we both print the datas, we get a number that we don't know how to calculate, but it will give us the standard deviation. The standard deviation for std.div is 2.48193. For variance is 6.515999 repeating. So over here we get it. Now we're gonna now talk about what is intermediate stats. So we're gonna talk about we talked about Python, basic Python and intermediate stats, but then after that, next time we're gonna talk about hypotheses and new alternatives on the next session. So intermediate stats. So that is we first it just means calculating the mutual relationship. So here we make two datas having different numbers and correlation equals np dot core k of xy and print. Oh wait, don't put that one here. I think I messed up over here. Intermediate stat. Oh no, core key of print, and we get 1.1, 1.1. Why? Because this is what we should get. So one is one right here, another one is right here. So one row of each column, one row of each column. So that's how it is. And this just means we can also minus it. So this is what I'm really saying. The 1, 2, 3, 4, 5, 6 and 2, 3, 4, 5, 6, 7 is 1 because we have 3 types of coef: constant, negative coef, or positive. We have constant because they're both going at the same rate and they both have the same variable. So 1 and 2, that's 1 again, as in 2 and 3, that's 1 and 3 and 4. That's how it is. So we have constant positive constant. Now we're gonna do what is linear regression. So we do import numpy as np from scalar.linear model import linear regression x np dot array is 1 2 3 4 5 y equals np dot array is 2 3 5 6 7 3 2 3 5 7 11. Correlation equals np dot core key of x y parentheses comma print correlation output will be Apple, this will be the Apple one. 0 point something means that's how accurate it is. So this is very accurate, that's the answer, and this is the very accurate. It's 1, and that's the accuracy. So now, how can we fit the data, or what model it is? We could do model linear regression, parentheses, nothing in it, model.fit xy, print double parentheses, double comma, as in coefficient of determination, parentheses r dash squared is model dot score xy, and the output will be coefficient of determination r squared 0.94.5. So I mistake here. This is just what the um between it is numbers. So this is y equals mx plus c. That's how we do it. This is what it is. So this is not the accuracy. I messed it up. This is the accuracy. So it's 94% accurate. And this number just means the correlation. So what is it going? It has constant. It's constant. So either ways you go backwards or up, it will be constant. How can we fit the data or what model it is? we can do it from I told you guys this. Now we're gonna do logistic regression from scalar dot liner underscore model import logistic regression model equals logistic regression model dot fit is parentheses x and y print coefficient of determination r parentheses r dash squared and model score xy output will be 0.6. So that is the model. So this is only 60% accurate. So we wanna always use linear regression more than regression model, regression, logistic regression model because it doesn't always give us the right answer. Maybe it does. Maybe it gives like the two first numbers correct, but the decimals might be very wrong. So that's why. So that's all we learned about today. What is uh, uh, intermediate stats and what is basic Python stats. I hope you guys understand this and do some coding, the coding with me, and I hope you guys learn and subscribe to my channel. Have a good day. Bye bye. Thank you.